Hello and welcome to Steps to Maths. In this video we're going to be looking at integers. So the first thing we're going to look at is the rules for adding integers. Now if you haven't seen integers before, this slide won't make any sense. However, if you're revising, it should make a reasonable bit of sense. So let's introduce you to the rules. So the rules for adding and subtracting natural numbers are: if you're going in the same direction, you add the numbers and label with the direction. If you're going in opposite directions, you subtract the numbers from each other and label with the number that had the bigger value. So that's adding and subtracting. What about multiplying and dividing? The rule for multiplying and dividing is quite simple. If the signs are different, the answer is negative, otherwise it's positive. So that's the rules, but for those of you who don't know what integers are yet, let's have a look at where they come from. So, first of all, here we have the number line. This is the number line for the counting numbers, which you already know as the natural numbers. It starts as 1 and continues upwards forever. Now, with the natural numbers, it's fairly straightforward. For example, if you were counting 5 things, like 5 apples, and you took away 3 apples, you'd end up with 2 apples. Similarly, if you had 5 apples, you could take away 4 apples, and still there's no problem. However, the problem arises when you have 5 apples and you want to take away 6 apples. Obviously, this can't be done. However, we often come across questions where we will have something similar to this, and we'll be asking the question, what is 5 take away 6? So, instead of the natural numbers number line, we're going to be looking at the integers number line. Now the integers number line is centered on 0. It continues upward like the natural numbers 1, 2, 3 all the way to infinity, and continues downwards -1, -2, -3 and downwards below. Now the natural numbers you've already used for counting. The integers, we're going to be using them more for comparing or as a reference to something. So the reference we're thinking about in this particular example is we're playing a game with somebody and we're 3 points ahead. So we're 3 points up. So in this issue, we're not wondering if we have 3 points or not. We're wondering how many points more than the other person that we have. That's what we're counting. So this means we can have more than the other person or less than the other person. Okay, so now it makes sense to say that you are 3 points ahead and you lose 5 points. So what's happened? Well, when you lose your first 3 points, you're down to equal. You're no longer ahead. When you lose another 2 points, the other person is now ahead of you and you're 2 points below him. Okay? So in the integers, we're thinking about comparing ourselves with another person or another value in some way. In this question, in this example, we're saying we were 3 points up and we lost 5 points. So now we're 2 points down compared to the other person. So here's our number line again, the number line for the integers. And we're going to look at a number of different examples. So the example, the first one is we start at +1, meaning we're up 1 point, and we gain another 8 points. So we have a total of 9 points. And this is exactly the same as it is for the natural numbers that you've done all the way through primary school. +1 + 8 = +9. Now, what if you're down a point? You're at -1, meaning you've less than the other person. So you're behind, but then you win 8 points. Now you know that you're ahead. You're ahead by 7. And the way you can do this on the number line is you count. Just count up in ones. Starting at -1 on the number line, you count up 1 to 0, and another 1 to 1, and then 2, then 3, then 4, then 5, then 6, and then 7. So you've counted up 8 places and you're at +7. You'll notice there of a little note that says you've gained more. What I'm saying is you've gained more than you were down. You were down 1 and you gained more, so you know that you're now ahead. Let's look at another example. You were 9 points ahead and you lost 7 points. Now you're only 2 points ahead. This is exactly the same as subtraction on the natural numbers that you're used to. +9 take away 7 = +2. In the fourth example, we say that we were 9 points ahead and we lost 11 points. So if you were 9 points ahead and you lost 11 points, you now know that you're behind. And if you start at the number 9 and you count down 11, you'll find you're at -2. You're 2 points behind. The note that I have there is to say that you've lost more, meaning you've lost more than you had. You've lost 11, which is more than you had 9. The fifth example, you're starting at -7, meaning you were 7 points behind and you gain 5 points. Okay, so you're catching up, but you haven't overtaken the other person. So if you look at the number line and start at -7, count up 5, you'll find you're at -2. You're just 2 points behind now. And the final example is when you're down 3 points, but you lose another 5 points. So you're counting down 5. You start at -3 and you go down 1, 2, 3, 4, 5, and you end up at -8, meaning you're even further down. So let's just have a little look through these particular issues. There's the 6 examples that we had in the last one with the little notes that I have beside them. Okay, so the normal case is a normal case. You already know how to do that. Let's have a look at the one where you gained more than you were behind. Okay, so you were behind by 1 and you gained 8 points. So you've gained more than you had lost. You had lost 1 point to go 1 point behind, and then you gained 8 points. So it's exactly the same as if you had 8 points and then lost 1. So if you had 8 points and then lost 1, you've gained more than you lost. You have 7 points, which is where the +7 comes up in the top example. The next one is just a normal example. You're used to doing that. And then you have +9 - 11. You've lost more than you had, which means you are now behind. Okay, so you started at +9 and you lost 11 points. So you lost 9 points down to 0 and you lost another 2 points. So if you lost more than you had, how much more than you had did you lose? So it's a strange sort of way to ask the question. You're asking how much more than you had did you lose? And the answer is 2. You've lost 2 more than you had. Okay, which results in you being 2 behind. The next question, you're catching up but still behind. And the question is, how much have you caught up? Well, you've caught up you've gone from -7, you've gained 5 points, so you've caught up by 5 points and you're just 2 behind. And the final example is where you go even further down. So what you're thinking about is just, I'm down 3 and I go down another 5. So you're only thinking about how far down you've gone. If you go down 3 and down another 5, you're down a total of 8. So you're 8 behind. So let's have a look at the rules for adding and subtracting natural numbers. So if you're going in the same direction, for example, when you're already down and you go further down, you're increasing how much down you are. If you're up and going up, you're increasing how much up you are, or how far ahead you are. Okay, so if you're 5 behind and you go another 10 behind, you're a total of 15 behind. If you're 5 up and you go another 10 up, you're a total of 15 up. So the rules for adding, if you're or going down, if you're going in the same direction, is you add the numbers and you label with the direction that you have. The rules for going in the opposite directions. So if you were already down and you were going up, or you were up and going down, excuse me, there's the rules that you need. Okay, so if you were up, if the rules basically are that you subtract the numbers from each other. Okay, if you're going in opposite directions, you want to know, have you started up but gone down more than you had? Have you started down and gone up more than you had? Okay, which means you go through the zero, and you either end up negative or positive. If you go down more than you have, meaning the bigger number is negative, you'll end up negative. If you go up more than you are down, you'll end up positive if the bigger number is positive. Here's a few examples. Okay, if you're down 8 and go down another 9, you've gone down a total of 17. So you add the numbers, 17, and you label -17. If you were up 9 and 8, you add them together, you get 17, you label them positive, you're +17, you're up 17. Okay, so remember with the integers, we're thinking how far up I am, how far down I am, rather than what I'm just counting. if you're going in different directions. You subtract the numbers and label with the bigger number. -5 plus 7, subtract the numbers, you get 2. The bigger number is positive, so you're up 2. If you're -7 plus 5, the bigger number is negative, so you're down 2. Similarly, from the other side. In fact, it's exactly the same. So -5 plus 7 is exactly the same result as being plus 7 and going down 5. So that's something we might come back to. Okay, so those are the rules. If you're going in the same direction, add them and label. If you're going in opposite directions, subtract and label. Okay, what about multiplying and dividing? Well, first of all, let's have a look at the rules, because the rules for integers are quite simple. When you're multiplying and dividing, if the signs are different, you get a negative answer. Otherwise, you get a positive answer. Let's have a look at why. So we're not really going to look at why, we're going to look at patterns. So as I told you before at the start of secondary school maths, we're going to be looking a lot more about patterns. Mathematics is about patterns. Watch the pattern, you can figure things out. So let's have a table of values. We're looking at the 5 times tables, but instead of counting up like we normally do, we're going to start at 3 and start counting down and see what the result is and look at the pattern. So we have 5 3s is 15, 5 2s is 10, 5 1s is 5, 5 0s is 0. Let's have a look at the pattern we're getting on the right hand side. 15, 10, 5, 0. What happens next? Well, if you look back at the integer number line, which hopefully you might have written down, you'll see you're counting down in 5s. If you count down 5 more, you're at -5. Count down another 5, -10. Count down another 5, you're at -15. So see the column on the right hand side, the tables, you're counting down. 15, 10, 5, 0, -5, -10, -15. Okay, so this is just the pattern that we're getting. We already know 5 times 3 is 15. We know that a positive number times a positive number gives you a positive answer. But what we're more interested in is at the bottom of the table, following this pattern, we find that a positive number multiplied by a negative number gives us a negative answer. Okay, so when the signs are different, you get a negative answer, because remember, multiplying is commutative. Commute meaning to switch places. So 5 times -3 is -15. -3 times 5 is -15. So a positive by a negative will give you a negative answer. If the signs are different, you'll get a negative answer. Now, let's look at a slightly different one. Now that we know that a positive by a negative number gives us a negative answer, we're going to look at a different times tables. We're going to look at -2 times tables. So integer 1, we're counting down 3, 2, 1, 0, -1, -2. We're doing the times tables of -2, and we have our integer results on the right hand side. So what we're looking for was we were looking for the pattern. We knew that a positive by a negative gives us a negative. So we knew that 3 times -2 gives us -6. We knew that 2 times -2 gives us -4, and 1 times -2 gives us -2. 0 multiplied by anything always gives us 0. So what happens now when we follow the pattern? Well, let's have a look at the pattern of our results. -6, -4, -2, 0. And the pattern that follows is +2 and +4. If you look at the integer number line and we start at -6, you can see we're counting up in 2s as we go through this, and we'll end up with positive numbers. So if you look at the bottom of the table there, the pattern that we've worked out is that a negative number multiplied by a negative number gives us a positive number. And this always works, okay? So we already knew a positive by a positive gives a positive. That's just normal. If you remember from the last slide, we saw that a positive by a negative gives a negative. And now in this slide, we see that a negative by a negative gives a positive. So now we know everything we need to know. If you multiply numbers with the same sign, you get a positive number. If you multiply numbers with a different sign, you get a negative number. So what about dividing? Okay, so we know that division is the inverse of multiplication. Except for 0, we can't divide by 0. That's something we can't do. So let's have a look at the tables we've already created and check the inverse. Okay, So we know that 5 times 3 is 15, which means that 15 divided by 3 is 5. And the same for the rest of them. 10 divided by 2 is 5. 5 divided by 1 is 5. 0, you cannot divide by 0. Let's ignore that. Negative 5 divided by negative 1 is positive 5. Okay, so we find a negative divided by a negative number gives us a positive number. So it's the same rule for division as it was for multiplication. Similarly, if we have a negative divided by a positive, for example, minus 6 divided by positive 3 gives us negative 2. So this is just the pattern again. This is just an example if you wanted to pause it and have a look at it. But we find that the division rule is exactly the same as for the multiplication rule. Okay, so there I'm just covering the rest of the rules. If its sign is the same, you get a positive integer. If the signs are different, you get a negative answer. So for integers, multiplying and dividing, the only thing you need to know is that if the signs are different, you get a negative answer, otherwise you get positive. The rules for adding and subtracting natural numbers: if you're going in the same direction, you add the numbers and label with the direction. If you're going in opposite directions, subtract and label with the bigger value. One thing that we haven't looked at here yet is what happens if you have an integer and you subtract another integer. What happens if I've got negative 5? Because we're thinking of the negative numbers as negative numbers, we're thinking of them as numbers rather than as subtractions. Okay, so that's something that we'll look at in another video.